All right, hey everybody. I invite you to join me for today's lesson on section 9.4, arcs and chords. Hope you're doing well. Sorry, I got a big bump on my nose. Hope that doesn't bother anybody. Anyway. All right, so there's several things related to arcs and chords that, actually there's 3 theorems that we need to learn in this lesson. All right, but first of all, if you have a circle A with chord XY that each chord will cut off 2 different arcs. We have the major arc XY, and then there's a minor arc XZY. The one that is the minor arc, in this case XY, we'll call that the arc of the chord. Okay. Now, if arc XY is congruent to arc XZ, then we could consider X the midpoint of arcs Y of YXZ. Okay? So if it's in the middle, if those are congruent, then there is such thing as a midpoint of an arc, is what this is saying. All right, so now that we can establish that the arc of a chord, let's go to theorem 9.4. In the same circle or in congruent circles, congruent arcs have congruent chords. And, at the same time, congruent chords have congruent arcs. It goes both ways. So if in our diagram over here, if we can say that chord YX is equal to YZ, if those links are congruent of those chords, then arc YZ is congruent to arc XZ. And vice versa. If we know the chords are congruent, then the arcs are congruent. I'm sorry, I said that backwards, but you got it. If the arcs are congruent, then the chords are congruent as well. So take a look at this example. Here we have if PS is equal to 12 and TR is equal to 15. So we have these 2 chords in our circle that have those lengths. Find the length of QR. Well, what's going to help us find the length of those chords is to know what the measurement of their related arcs. So arc TR has a measure of 80. That's misrepresented there. That should be marked. That should be TR, not QR. And then arc PS has a measurement of 70, 50 plus 20. Well, look over at arc RQ. It also has a measurement of 70. So because those arcs are congruent, those chords are congruent. So QR is congruent to PS, so therefore QR is equal to 12. So on a lot of these questions, to find the length of an arc, or the measurement of an arc, you need to know the length of the chord, and vice versa. All right, I want you to try these 4 questions based on this. I'm going to give you a hint here in this first one. It's asking about to find the measurement of these arcs. Well, it gives us pieces of these chords. So this chord right here, YX, we know has a length of 22. These pieces of V and X have 12 and 10. So VX will have a length of 22. See, use that hint and see if you can use related ideas to answer these 4 questions. I'll display answers here in a second. An additional hint on number 2, the only arc that we don't know the length of is AD. All of the arcs added together will add up to 360. And then on number 3, it tells us that the chord PR is congruent to chord RQ. So those arcs will be congruent as well. Those ideas right there will help you. Okay, check these answers, and of course be ready to ask questions about them if you have questions. All right, so if we have congruent chords, we have congruent arcs and vice versa. Here is the next piece of this. A diameter, or a radius, that is perpendicular to a chord bisects the chord and its arc. So the same thing is true if it says diameter, but it would also be true if it's a radius. So in this example over here, because AB is perpendicular to CD, we know that those 2 pieces of the chord are congruent. It bisects it. And also, therefore, we can say that the arcs, CB is congruent to BD. It cuts the arc in half as well. Let's look at this example down here. If we know in circle A that SQ is has a length of 12, and this diameter, or this radius, is perpendicular, well, we know that it splits it up into 2 congruent pieces, 6 and 6. We also know that AT is 8, and we're trying to find the length of PR. Now, a hint on every single circle question is this. Find the radii. AS is the hypotenuse of this right triangle that's created with AT and ST, but it's also the radius of the circle. AR is a radius and PA is a radius. So if you know what AS is, you should be able to find the diameter. I'll do the Pythagorean theorem to figure out what AS is equal to. 6, 8, that is a common one. 10, AS is equal to 10. That's the radius. So if I know the radius, I should be able to figure out the diameter. Multiply by 2, it's 20. Try these guys right here, keeping in mind a radius, right triangles, the perpendicular piece cuts the chord in half and the arc in half. Excuse me. All right, so here's the answers. Again, we'll go over these in class. All right, next piece of this. Here, Theorem 9.4 says, if in the same circle or congruent circles, chords are equally distant from the center, chords equally distant from the center are congruent. So if a chord in a circle is the same distance from the center as another chord, then those two chords are congruent, and vice versa. If you have congruent chords, they are equally distant from the center. So this thing goes forwards and backwards. At this point in time, I would like for you to write roar, the noise you just heard, to the right of that circle that we're working on here in this theorem. All right, so in this example here, if OX is equal to OY, up in here, if OX is equal to OY, that is the distance between the chords, because those are congruent. That means that these chords are also congruent. AB is congruent with CD. And vice versa. If we know that those chords are congruent, then we can also say that those distances are the same. All right, so let's look at an example where this idea will come into play. We got circle A right over here. It tells us that FL has a length of 3. Because it's perpendicular here, if FL is 3, well, so is LG. Okay, next it says GO has a length of 5. GO is a radius. Look, it looks like it says go radius, R-A-D-I-O, yes, go radius. Anyway, so if it's a radius, it has a length of 5 here, well, all of the radii have the same length. So you can go ahead and say that OJ has a length of 5. Do that every single time. Okay, so now, how can we use this to find the length of HJ? Well, I think we're going to have to figure out what this side of this triangle is equal to before we can do that. Well, it gave us information about this triangle. I know the 3 of this triangle, 5 of this triangle. We need to figure out what this length right here is. Oh yeah, OP has a length of 4. So if I have, this has a length of 4, I got 5 over here, 3, 4, 5 triangle. What is LO? It's equal to 4 as well. So those distances that, because of this 3, because it's a 3, 4, 5 triangle, LO has a length of 4. It gave us that OP has a length of 4. Same distances, that means the chords are the same length as well. So FG has a length of what? Well, it's the same as HG. FG equals 6, so does HJ. This one sounds weird, but just knowing that the chords have equal length from the center, they are therefore congruent. Give these next 3 a shot, and I may give you a hint on number 12. So I'll give these 3 a shot, and I'll display answers. How did you do? Okay. On number 12, sketch the circle. See if you can pause this and see if you can do it by yourself first. I'm going to help you with the diagram in just a second. So here is a sketch of what we're talking about here. The radius has a length of 17. How many radii do you see in the diagram that I just drew? 1, 2, and 3. The reason I drew it this way is because AB is going to get chopped in half. We're about to know that this has a length of 17, so does this. This gets chopped in half, 15, 15. And it's asking us to figure out this distance right here, the length of it. So if that's 17 and that's 15, I think you can figure that out. 13 has a very similar sketch. See if you can give those a try. I'll display answers here in a second. All right, there they are. I hope you did well. We'll discuss this, of course. Get some rest. Man, we got a lot going on.